All right, section 9-4, compositions of isometries. All right, so use the information below to answer questions 1 through 3. So the image of angle J is angle J prime, and the image of angle K is angle K prime. So circle the corresponding sides, and it would be this. So a transformation, triangle JKQ to triangle J prime, K prime, Q prime is a reflection. So an isometry is a transformation that preserves distance or length. So translations, reflections, rotations, and glide reflections are all isometries. Okay. So in a transformation, the original figure is called the pre-image. The resulting figure is called the image. So circle the type of transformation that maps each xy to x minus 8 and y plus 2. Well, we noticed we just moved it over 8 units and 2 units, so this is a translation. There are only 4 isometries: a translation, a rotation, a reflection, or a glide reflection. So theorem 9.1, the composition of 2 or more isometries is also an isometry. Okay, so 9.2, so reflections across parallel lines. So a composition of reflections across 2 parallel lines is a translation. So you can write this composition as the following. So we first reflected R about M and then reflected about L, or you could just say we ended up with this. Okay. Problem number 1. Okay, to draw parallel lines L and M, draw J between L and M, and what is the image of this composition? So 6, we're going to reflect J across the line L. PA equals A, P prime, so P prime equals 2 times A, P prime. If we reflect the image across line M, then P prime B equals B, P double prime. So P prime, P double prime equals 2 times B, P prime. So P moved a total distance of 2 times AB. Okay. So composition of reflections across 2 intersecting lines is called a rotation. You can write this composition as a reflection about L composed with the reflection about M, or this thing. So the composition has the following properties. The figure is rotated about a point where the 2 lines intersect, in this case point Q. All right. So triangle ABC is rotated counterclockwise around the point of intersection. All right, for a glide reflection. Triangle TEX is shown in the graph to the right. What is the image of triangle TEX for the glide reflection? We're going to reflect about the y equals -2 line, and then we're going to translate it about the 1 unit in the x and 0 units in the y. Okay. So the vertices of triangle TEX are the following. T is -5, 2, E is -1, 3, and X is -2, 1. The translation rule, 1, 0 for TX, and the reflection rule or line is Y equals -2. I need the image. So first, I'm going to use the rule to translate. Then I'm going to reflect. Okay, I'll cross the line of reflection. Okay. So using the translation rule, 1, 0, I move the triangle right 1 unit. Using the reflection rule about the line y equals -2, then the new vertices become -4, -6, 0, -7, and -1, -5. Okay. So if I reflected triangle DEF first across line M and then across line N, your friend says you get the same result by reflecting DEF first across line N and by line M. What's your error? Okay, so first let's reflect line triangle DEF over line M. So then I get E prime, I get D prime, and I get F prime. Then let's reflect this image over line N. So this was E prime from the previous picture. This was D prime, and this was F prime. Okay, so then this becomes F prime, this becomes D prime, and this becomes E prime, or double primes, we should say. So my friend says I can do the following. Reflected about line N first, so then I get F prime, then I get E prime, and then I get D prime. So this was F prime, this was E prime, and then this was D prime. Flipping it over this way, I get F double prime, I get D double prime, and I give E double prime. So if the reflection is across M, then N, the rotation is clockwise. If the reflection is across N, then M, the rotation is counterclockwise. And that's the end of this section.